Facebook has been asking this question for 16 times over the past 6 months. But given the array of meeting times interval, where each interval has start and end, we need to return the minimum number of conference required. Think about in the real world that you need a conference room to have the meeting. Let's say if the meeting starts from 0 until 30, that means we're fitting one room to have this meeting. However, we have another meeting from 5 to 10. Since the room is already occupied, we need another room to fit this meeting. We have the third meeting that starts at 15. Now we know that the second meeting ends at 10, so we don't need a second room anymore. We can just fit the third meeting to the second room. So at total, we just need at least 2 rooms. Let's consider the other given array here. First, let's sort the array based on the start time. We put the first interval in the first room, and we only need to mark the end time 10, because we know that this room will end at 10. As we are moving to the next interval, we know that this meeting starts at 2, and we couldn't use the first room, so we need to create a second room, and we mark the end time 7. On the third meeting, we know that it starts at 3, so we need to create a third room. We mark the end time 19. As we are moving to the fourth meeting, we know that it starts at 8. We're looking for the rooms, and we know that the minimum end time is 7, so we can use the second room. Now we replace 7 to 12 as the end time of the fourth meeting. On the fifth meeting, it starts at 10. We can use the first room since it ends at 10. So we replace 10 as the end time, which is 20. As we're moving to the sixth meeting, we know that it starts at 11. So we need to create a fourth room, and it ends at 30. And here's the Pseudo code. Every time we need to compare the current interval start time with the mean rooms. The minimum values from the rooms, that means the earliest time we can start from that room. So if the start time is less than the earliest time we can use the room, that means we need an extra room. So we need to append the end time of the meeting to the rooms, because we only care about when does the room end. If the start time is greater or equal to the earliest time from the room, that means there exists a room that we can wait until we finish so that we can use the room to start the current meeting. So we need to find the earliest room, replace the room valued with the end time of the current, because we are using the room right now. Let's convert the Pseudo code into Python code. I'm going to talk about the heap approach, which is using the heap data structure. In Python, the heap is called the minimum heap. That means the parent node is always smaller than the child node, and the root of the heap is always the smallest. The reasons I'm using heap data structure is that it can make convenience for us to replace the minimum of the rooms. In this case, we just need to reach out to the root of the heap, replace it with the current interval end time. If I replace the minimum value 0 to 5 in the heap, it will restructure the whole heap. So it will bring 1 to the root, and then it will bring down 5 to the end. That way, we always maintain the parent node is less than the child node. So by using the heap, first I'm declare an empty array as the rooms variable. I push the first interval, the end time, into the room as we are occupying the first room. If there is an overlap, that means I couldn't find a room to start the current meeting. So I need to create a new room like I append. In the heap, it's called push. Else, that means we can use the earliest room to start the current meeting. In the heap, it's called push and pop. So at first, it pop the minimum value in the heap, and I push the end time in the heap. Finally, we return the length of the rooms. In terms of the time complexity of this question, the sorted algorithm will give us O nlogn, and the heap operation will take us log n time. So at total, we have nlogn. If you like this channel, please click like and subscribe. Thank you.